Welcome to this Advanced Malware Tactics Part 3. In this video series, this is the Part 3. In first two parts, we discussed about the core concepts of Windows, and then in the second part, we took an introduction about process injection, what is the technique about and why it is used. Now, in this part, in this Part 3, we will discuss the basic building blocks of process injection. So, no matter what process injection type you come across, they use these three primitives, and the way they use these three primitives or with different APIs, that might differ, but the overall concept of injecting the code in process injection in any process injection type, that remains the same. So the allocation, write, execution, this sequence will remain the same no matter which process injection you are studying. And execution, in this stage, there are different APIs that are abused, different system calls that are abused, and that's why in execution you will see the variety. But allocation and write, that is mostly used using the same APIs and same functions in Windows. So let's do a deep dive, a theoretical deep dive, not a practical one, a theoretical deep dive into each of these stages of allocation, write, and execution, and understand how the process injection works. Let's get started then with the example of an application. Let's understand first that when an application starts, what happens in Windows. Like whenever an application starts, there's a process that gets assigned to it. And in the first part of the video, we have already discussed that a process is a running instance of an application. So an application will need at least one process to serve the user. So whenever an application starts, OS, what it does is, out of its physical memory, it assigns a virtual address space to every application, so that the whole, whatever functionality, whatever feature, whatever the application is doing, that happens within its own virtual address space. So this physical address space, this physical memory, that gets divided into these several virtual address spaces, that is reserved for every application, and then that becomes kind of a private room for every application. For instance, say if you have started Chrome, if you've started Word, if you're using Notepad, all these three processes, they are all running in their own private virtual address space, in their own room, and at no point of time then one process will step into another process's virtual address space and interfere there. So this is how the application works. Why I'm discussing about this address space, virtual address space, you will understand as we progress through the video. Now, as I told you that one virtual address space will not be stepped by another process's virtual address space, but there are legitimate reasons where one process would go ahead and reserve a space in another process's address space and then execute the code there. There are legitimate scenarios. By design, every operating system, let it be Windows, Linux, Unix, Android, they all work on this inter-process communication phenomena. So they all have this by design, where inter-process communication is allowed, where one process can go ahead and talk to another process's virtual address space, reserve the space there, execute its code there. This is all by design allowed. And attackers, they do a lot of OS reverse engineering, because before designing a attack technique, and so they are studying these scenarios, they are doing a deep dive into OS reverse engineering, and accordingly they are exploiting these legitimate scenarios. So in process injection also the same thing happens. This legitimate scenario of allowing one process to communicate with the other process, and to allow one process to reserve the address space in another process and execute its code. This scenario is exploited and abused in process injection. As we progress through the video, you will understand it more clearly. So let's first discuss some of the common scenarios why this inter-process communication phenomena is allowed in operating systems. One is the debugging tools for the applications to debug their application, to troubleshoot their application, to investigate their application. They need to attach their debugging tools process to applications process, and they will also write, they will also read from another process's address space. So because of debugging tools also, this inter-process communication is allowed. Another thing is automation. Automation is the boom of the current world, and a lot of automation is happening where a lot of manual activities of an application are automated, and because of that also this inter-process communication is allowed. This talking of one process to another, and the activity of one process reserving the space in another process and then executing its own code there, that is allowed. And that is automation and testing is also one use case why you would see virtual address space crawling by one process into another. Then there are software updates. Whenever there is a software update, whenever application gets patched, maybe in runtime or maybe offline, you see this injecting of code from the patch into the application, and behind the scene maybe trusted installer.exe or some other Windows host process is doing this activity of patching of the Windows host, of the Windows, and also the application level patches. So in those scenarios also this inter-process communication is allowed, especially if you're patching some applications in the live while they are running in the runtime, then also this inter-process communication is allowed. This injecting of code from the update to the application is allowed. So attackers, as I said, they have in-depth knowledge of this OS reverse engineering, and that is what they use to attack. And in process injection they use this knowledge of inter-process communication, and accordingly they do the process injection. Now let's understand how the the allocation works, what an attacker does to inject its code and get its code executed in another process's virtual address space. What are the stages that the attacker takes, that he has to go through. So before an attacker's process can write to another process's address space, so say for example here, if this is attacker process 1 and it is trying to exploit the address space of another process, then first it will have to allocate a space there. It will have to reserve a space there in order to go ahead and copy its code there and then get its code executed. Now why would an attacker do this? Why would it get its code executed, get its code run in another process's address space? To hide. Because say if an attacker is exploiting, say, a Windows trusted explorer.exe native process. Now explorer.exe is a native process in Windows. It is trusted by anti-malwares and for all its activities. So if an attacker is able to inject its code into the explorer.exe process and is able to get its code executed there, then the whole activity the attackers will be able to run it will be in the context of this explorer.exe. Then in that way that will be a less suspicious activity. If an attacker is executing his process, doing all the malicious activities, then since attacker's process is a third party foreign process to the OS, that will get caught easily, raise alarms within anti-malware softwares and within OS. So that is the reason in process injection the attackers, they try to hide their code into another process's address space, and they try to execute their code from the other process's address space, so that all the malicious activity, then whatever the attacker is trying to run, say if an attacker is trying to make CNC calls to his server and trying to get the remote of the client system, then in that case the explorer.exe, which the attacker has abused, that will try to call the CNC server, that will try to give the remote away to the attacker. So the whole this malicious activity, that is running in the context of the explorer.exe and not the attacker's process, which is then less suspicious and is a trusted activity and less chances of getting caught. So let's understand these stages a little bit more in depth. So allocation, as I said, is the first stage using which the attacker will reserve a space in the process that he is trying to target, and the allocation is done by calling the API virtual alloc x. So this is a user mode API. If you remember from the first part of our video, I had shown you that all the 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 user mode APIs, they will use a suffix like EX and Z and W and these kind of suffix they use. And so by looking at this EX suffix, you can understand that this is a user mode API. This is available for calling in the user mode. And what is user mode, we have already discussed in the first part. So attacker will use this virtual alloc_x API. He will call this function, and then using this he will give the target process, and then he will reserve a space. So using this he will reserve the space. After the space is reserved, then comes the writing part, where the attacker will copy its code into the reserved address space of another process, and this will be done by using the write process memory API. Now this write process memory API, using this the attacker will be able to copy its code into the address space of another process, and then in the execution stage, once the code is copied, now the attacker has to get its code executed. Only then the malicious activity will start of maybe calling to the CNC servers or giving the remote away. So that all will happen only when the code gets executed, which is inserted by the attacker. So for inserting for getting the code executed, attackers can exploit in whatever traditional process injection techniques that I have seen and studied. In that, the attackers, they exploit these user mode APIs like set windows hookx, CreateRemoteThread. About CreateRemoteThread we will discuss in a little bit in detail on the next slides. 2 words about set windows hookx API. This exploits the hook procedure within an application. If I have to explain it to you very briefly, then there are gaming applications, there are Photoshop applications that require to monitor the user clicks, that are monitoring the user clicks in order to serve to the user. So those APIs, they monitor the user clicks and everything by a hook procedure, and there set windows hookx is used. And I will not complicate this by discussing further about set windows hookx, because I am trying to build a foundational understanding in your head about process injection, about allocation, writing and execution, about these stages. So let's directly jump to CreateRemoteThread, which is the most direct way of process injection, most direct way of getting your code execution. And CreateRemoteThread was very simple, very powerful. It was widely used, and that is one of the reason why now anti-malware softwares are capable enough to catch a CreateRemoteThread traditional injection type, and it is not very much used now, although some old malware campaigns still use CreateRemoteThread, but the EDR can easily catch the CreateRemoteThread because of its direct method of execution. What is its direct method of execution? So the attacker, when he has gotten his code copied and inserted into the virtual address, into the reserved address space of another process, then simply the attacker will call this CreateRemoteThread API, and using which he will create a worker here, and that worker will be dedicated to run the attacker's code. So this is pretty simple and direct method of process injection. Now in the first part of our video, if you remember, we discussed about the processes, we discussed about these worker threads. In Windows, whenever a process starts, Windows assigns some threads. These threads are like these workers who are running this process. So CreateRemoteThread is an API using which you will create one more worker, and you will then dedicate that worker to run your own malicious code within that address space. So the other workers, they will be busy in executing the code of whatever the process is running, but this one worker, this will go into executing your code. There can be one or more workers that will be required to run this code, but using CreateRemoteThread, then the attacker gets the execution done. So I hope then that with this video now it is clear to you that allocation and write, these two stages of reserving a space and writing, they are mostly done and only done using the APIs that I was showing you, that is the virtual alloc-x API and write process memory API, because there you just have to copy the reserve a space, copy the code. So always, in almost all process injection techniques, those are the only two APIs that are used, that are called. But in execution stage, you will have to, attackers, when they see that okay, one execution technique has there is a detection available for it, anti-malwares are catching it, then they will move on to abusing the next API in execution stage, maybe something else. But the allocation and writing stage, there they use the same APIs, because there the activity is not raising any alarm, because there is a lot of legitimate use case behind it. So that is the reason in the execution stage you will see the variations, like different APIs, different system calls getting abused. But in allocation, in writing, these APIs will be common, like virtual alloc-x and write process memory. This will be common for allocating the space and writing the code. And no matter which process injection, this sequence will always follow. Like first the process will allocate a space, then it will write its code, and then in the execution it will find some or the other system call or API to abuse. So I hope then that with this video you have gained a good understanding of how these building blocks they contribute in creating of process injection, and how different process injection techniques they utilize this allocation, writing, and they go through this sequence and execution. And in the part 4 then we will discuss about different process injections that are there, and we will specifically discuss about the DLL injection with an example of QuakeBot malware. The QuakeBot malware, it is known to do a DLL injections. It is a very old malware, and we will discuss that with an example. We will not be doing a practical, we will be doing a theoretical deep dive where I will be showing you a script of QuakeBot malware that I have handy, that I retrieved during one of my investigations, and what commandlets are there in the script using which the attackers do this DLL injection. We will discuss that, and then your understanding of this process injection will become more deep. And then when we progress to part 5, where we will be discussing the new process injection techniques that were discovered, you will be able to then grasp that more clearly. Alright then, if you have liked this video and if this was really of value to you, then don't forget to subscribe and share and like this video. That will motivate me to create more such videos. Alright, thank you. I will see you in the next video then.